I'm Amanda Locker, and I'm here with Aaron Bedra and Michael Feathers, and we're about to talk about security.
Cheers.
Cheers. Okay. So, yeah, Aaron, you've been involved in security for quite a while now. It seems like a bit of a passion for you. So, tell us more about that, Aaron.
I took a kind of a dive through languages of closure and Ruby and things like that for a few years, but kind of always had my ear to the ground with security and did it even before professionally, really. Penetration testing, digital forensics, and things like that, kind of very, very early in my career. Kind of went from hobby to job to kind of career path for me eventually.
Yeah, no, it's cool because it seems like it's something that's really gaining a lot of attention these days.
It is, yeah.
What's funny is that there's so many developers I know that basically it's almost like it's completely peripheral concern. They just don't really think about it all that much except when it impinges on their work, right?
Yeah.
How do you feel about that?
For me, it's kind of it's a way of life, right? It's a way of thinking. It's a way of designing systems. It definitely shouldn't get in the way. Really what it should do is enable you to do more faster, right? Just like any tool we use, and any idea, any concept we use in programming, good design yields productivity.
So you ever run into developers that just don't want to think about it?
Sure, absolutely, all the time. And
me too.
That's okay, right? I mean, that's not everybody wants to think about this all the time.
Yeah.
Especially when they're writing their code, right? You want it to work. You want to get it out the door. You want to deliver. Right? You have a business to run. You have money to make, and when you have to stop that for something, for anything, that's seen as kind of a detriment.
Yeah. I just kind of wonder though whether it really should be a little bit more deeply integrated.
Yeah, I mean, absolutely. It's definitely.
It seems like it's a bit kind of. Still feels like a bit of an afterthought, but it's funny now. Like most areas of development, it's like somebody can go and take some particular area like. User interaction and stuff like that, and say that, hey, this is a very primary thing, and we want to go and push it forward in the development process and make it really something we highlight. And it feels like with Agile over the years, we've kind of like pushed that aside and said, look, it's just really a matter of getting something out there, and as the concern arises, we start to deal with it. But I'm wondering with security if that's really where we should be.
I mean, it's always been baked in versus tacked on later, right? And security baked in, usually is a better design, right?
Yeah.
And actually, you do a lot less. Your system is less complicated when you build the security in, because when you tack it on later, you end up having to add a bunch of knobs to everything you're doing, and you don't really get all the way to the core of your system.
Yeah.
And so it becomes harder. You have to create additional abstractions and additional ideas around the software you're writing, just
like
to keep things safe.
Yeah.
But if you design things from the ground up with security in mind, it makes it go a lot faster, a lot easier.
Yeah, it just feels like it's kind of weird right now because there is like all that peripheral talk about security and people, who are experts in security, but I just don't, I'm not quite sure where we really go as far as going in developing the mindset among developers, to
it's odd, right? I mean, the kind of some of the older ways of security thinking were always no, right? You can't do that, or you have to stop and fix this before you can push something out the door, or basically it's roadblocks, right? Security is always seen as a roadblock. It's a perception problem, really, because in the end, right now, our businesses move so fast, it's about creative ways of saying yes. And that's really the point here.
Yeah, but there's an analogy there in a way. It's kind of like with QA has been in that role in a sense, kind of like, okay, well, it's like, no, this isn't ready, this kind of thing.
Yeah.
I wonder how much of this is really an artifact of having separate teams of people rather than going and having, kind of like coordinated action to go and say, look,
absolutely, yeah.
I'm not saying no, but I'm basically with you early enough in the process to go and say, hey, this is how we get to yes.
Absolutely, yeah. I mean, it's about being part of every day and being involved the entire time, because then you put things out the door on time. And at the end of the day, that's the important thing, right? I mean, you don't want to be attacked, you don't want to be compromised, but you also need to ship software to make money.
Yeah.
And that's really the point of running your business, right? Unless your business is actually just doing security, right, as a consultancy or something else.
Yeah.
At the bottom line is you have to function as a business. And you really, it's that kind of black and white feeling that we've had in the past too, of yes or no, secure, unsecure, or insecure. It's tough because we end up in that way of thinking, but really it's about a state of risk tolerance. Right?
Yeah. Have you run into situations where basically people are encountering unanticipatable security concerns in their application development?
I mean, there's one that happened just a month and a half ago or so. I mean, Ruby on Rails had a giant 0-day exploit, and everything's fine, and then all of a sudden it's not. And
Yeah,
it's so not
right.
fine that somebody can just go and, run whatever code they want on your system, and you're impacted, right? And it's the response time, even if it was, 12 hours, which is not great, but also not that bad, was enough time for, a worm to propagate out of the internet, just finding Rails servers and having fun.
That's funny, because I kind of wonder whether that really is, whether that should be considered unanticipatable in a sense, because that kind of vulnerability
Absolutely.
seems like, it's a strange thing.
There's a really good book called Waltzing with Bears. It's actually kind of about risk tolerance, risk management in general.
It's Tony Marco and...
I can't remember the authors, but I remember reading the book, and they kind of refer to things as like the meteor event, right? Asteroid hits the planet, there's not much you can do, right? You have to focus on the things that are relevant, right? The things you see coming, you're never going to predict everything, right? And there's that list of exploits sitting out on the market for sale that haven't been published yet. There's always that one last thing that can get you.
So here's a question. It sounds like the security discussion, you have a certain amount of control over security from the application level, the code that you're writing, but there's a whole stack there. And it makes me think back to some DevOps discussions that we've had and looking at the entire system. So not just the application code, but looking at the stack, the libraries you're choosing, the hardware it's running on, the infrastructure. How does security affect your decisions in each of these areas? Like, for instance, can you look at it and say, okay, well, here's our process for rolling out a new driver because there's an issue with the underlying Ethernet driver, or a new kernel for the underlying VM that we're running on, because only certain types of vulnerabilities are at the application layer, and there's a whole slew of them that come through.
There's a giant stack underneath you. It is standing on the shoulders of giants, right? There's a ton of stuff there. And, it really depends on your business and how sensitive you are to those needs. I mean, you can get as detailed as understanding who's manufacturing your chips and making sure somebody hasn't paid them to embed, compromised firmware, right? I mean, that happens. It's espionage or just legitimate attacks. So it can go all the way down to the silicon when it comes down to it. So you have to weigh the benefit.
It's funny with that too, because the question kind of presupposes we're just basically in software also, right? And not just software and hardware, but it's kind of funny because at least the reading I've been doing security, so a lot of people I've been talking to, they're basically pointing out that it's really so much broader in essence. It's like the whole notion of even what features you choose in an application basically will permit even certain social engineering exploits and stuff along those lines that are, I think that quite often us as, we as software developers, we tend to think an awful lot about this is software, how we basically protect ourselves at these various layers and stuff. But it's like an entire risk mindset across the entire business.
Absolutely. I mean, and there's definitely a saying that's gone around that amateurs attack systems, professionals attack people. Right? Social engineering is
key thing.
Really the easiest way in most of the time. And there's also the combination of social engineering plus actual technical exploits. The RSA event that happened a while back was a combination of convincing somebody at HR to open a spreadsheet that had a zero-day exploit to Excel that kind of launched the entire chain of events that happened from there. So it was a combination of social engineering and an actual technical exploit.
So it's a definite side effect of doing things better technically, I guess.
Yeah,
it's the moral hazard of making things
that's
better
right.
technically.
You make things easier as a function of business, right? And that technology is not well understood. But it's a tool, and you can use it for all kinds of reasons.
Wow.
I feel like security is such a huge topic, and as we've talked about, hits every level of development. Any software that you're thinking about has 100 security risks or more. And I'm wondering, since it feels so big, and I feel like I can't know everything. There's no way I can learn everything today. Is there some sage advice that you can give me as a developer, or as somebody who's a consultant in the software industry, or as somebody who's an architect? What should I be thinking day to day to really just help my company be a little more secure?
I mean, it really starts with just culture, right? Just the way you think about designing and building things. Obviously education on just the basic application security stuff is important. If you're in the web space, the OWASP top 10, pay attention to that. Finding tools like WebGoat, they'll help you kind of learn the techniques for attacking a site and just attack it, right? Attack your own sites. Make sure that you understand that once you get there, then you realize how an attacker might come at your system. Then you make those defenses. So you build those defenses based on understanding how the attacks work. I mean, that's a very small part of the stack, but the rest of it, right? The patching their servers, providing firewalls, IDS, that kind of stuff. There's kind of a prescribed thing there, right? Everybody's system is different. The solutions are different, but there is, there's a way to get there that isn't as complicated as working it into the software you're writing, right? So at the application security level, there's a lot more to think about because it is that different. It's not just, everybody uses the same network stack, more or less, right? Everybody uses the same kind of basic principles for communicating between systems. Not everybody uses the same language, framework, libraries. There's just so much more levels of variance between the software we're writing. And so it gets complicated.
It's just striking to me because it seems like there's such a strong analogy here between QA and this and security, just in the sense that it seems an awful lot of it is really about going and cultivating an adversarial mindset.
Absolutely, and one of the best things you can do is actually to train all of the people in QA how to attack a site and let them do that during their QA process. I mean, the QA process should include security, and it's not hard, right? Some of the best attack tools are made by Google and Microsoft and Opera and Mozilla, right? The browsers that actually, when Firebug came around and all the web inspector tools came around, that's it, right? I mean, that's how a lot of this works. It's not like somebody bought a $100,000 advanced attack tool. Yeah. They had a browser and they had a little proxy sitting behind it, and they just tamper with data, and that's it. Right? It's a pretty trivial thing to learn.
Yeah. Firesheep is a great example of something which is zero barrier to entry,
absolutely,
and quick to own.
Yeah, Firesheep is definitely one of those look how real this is kind of tools. It is so close to us. It's so easy. There's this interesting perception that security, being a hacker is complicated and tough, and it can be, right? There are definitely very complicated exploits that require understanding of systems, really deep understanding of systems. But most of them are really trivial and really simple to pull off.
And often have to do with not patching your server correctly.
Yeah, I mean, if you just keep up on the basics, right? Just patching when patches come out, just doing the updates, you're doing a lot better than most people, to be honest. I mean, the problem is it's difficult, and when your culture doesn't allow it, and there's that kind of mindset where you own your environment or your environment owns you, right? And you get to that stage where you have the freedom to command your environment, and when you get there, patching is easy. When your environment owns you, it's not, right? And then in places like that, the problem really isn't the fact that you can't patch because this or that came out. The problem is you don't own your environment, right? It's too complicated, or it's too brittle. And this all comes back to just designing resilient systems, right? Designing good systems that function in the face of, anything, right? Just knowing that eventually it's going to be broken, right? I mean, when a system becomes big enough, some part of it will always be broken. And you just have to accept that. And when you build systems to kind of just accept that as a status quo, then everything becomes more resilient, and then you can start doing the patching and everything else. So it just becomes good architecture at that point.
Do you think it makes sense to put effort into intrusion detection tools like Tripwire or pattern detection? Yeah. Or are these things, at what point should you introduce these, and what benefits do they provide?
Yeah, I mean, so any kind of data is data, right? And you have to find out whether it's signal or noise. So a lot of these systems, IDS tools, the forensic tools, Tripwire, Samhain, things like that, they're all useful. They just require tuning. And false positives, high rates of false positives are tough, right? Because there's a lot of noise. But if you didn't have false positives, you're probably doing something wrong, right? Like there's that threshold of when the false positives stop, you have to wonder if anything's happening. So it's good and bad, right? But data, the more data you have, the more decisions you're able to make. And so it's really about collecting all the data you can. So if you can set that kind of stuff up and you can put it into a state of it's functioning and it's alerting sometimes and it hasn't gotten so noisy that you ignore it, then it's okay. But there's that problem where you turn it on and it's really noisy and everybody just forgets about it. They filter it off in their mail and never see it again, and it's just this noisy little thing in the background sending me email that I don't care about, right? So there's that really fine line of actually caring about the things you're putting together. So you have to be careful about how you introduce things and how much data you're giving everybody, right? Because eventually they're going to ignore it. It's too much.
I've heard that described as alert fatigue.
Yeah, absolutely. That's very much, good word for it.
One thing that's very interesting to me is someone who's a bit of an outsider is the whole gamesmanship aspect of this, and the whole thing of kind of like an escalating, war, arms race, pretty much. And I kind of wonder if this ever comes up, where there's like a series of exploits where a security professional might choose to have a business ignore those rather than actually escalate.
It's possible, right?
It feels like an interesting.
At the end of the day, this all comes down to acceptable levels of risk,
Yeah.
right? If you know that the impact from a compromise is $10,000, and that's a drop to the bucket of your company, and you don't suffer any reputation damage or brand damage, they basically shut off one of your servers that you barely use every now and again that collects what somebody ate for lunch, right? It's response. So it costs you money to respond to it, basically.
Yeah.
Okay. It didn't stop business. It didn't affect things. You didn't break compliance, right? The impact is low. The loss, the actual loss from an event is so low that you move on, right? It might cost you more to go and fix this thing in opportunity costs and some other function of your business, right? To pull people off and fix this, than it would be just let it happen, right? Or just turn the system off altogether. But you have to understand and be able to understand the impact of an event and speak in dollars and cents, right? Nobody cares that this thing is vulnerable to that exploit. They care that if this happens, my business loses this much money, right? Everybody understands that. Doesn't matter who you talk to. It's very clear. And so it's not up to us as implementers of a system or designers of a system to make those calls. It's up to us to inform everybody what the impact of a loss is and let them choose what the business should do. And too many of us get wrapped up into saying we have to fix everything. It's a problem, and you have to understand that it's always going to be a problem, right? You can't live in this black and white world of absolutes. You have to understand that it's okay sometimes.
Yeah.
I really enjoyed your talk at SpeakerConf. I don't know if you want to make any of that public at the moment, but you talked a bit about if there's somebody that you find or you suspect that they have malintent, you do something to make them think that they've been successful.
Yeah, the act of honeypotting, right? I actually talked about it here at the conference as well, GOTO. So I actually had built that system out and I've open sourced it now. So it really is, it's fun to study them, right? Study the behavior, right? You don't always just flat out deny somebody access. Sometimes you put them in a little corner and watch what they do, right? And then what you're getting is actual signal, right? You're seeing an attack, you're seeing what they're doing, and you can study that. And actually, if you capture the data the right way, you can replay it and train a model to learn, right? It's a supervised learning exercise, right? Where you can say, yeah, this is an attack, and here's what it looks like. And you can just play that through your supervised learning, and all of a sudden it sorts out what that is. And next time it happens, it sees, oh, that's an attack. Let's go ahead and classify that as an attack and maybe block them later. So it depends, right? Have I seen it before? Have I not? Is it different from the past time I've seen it? So you can choose whether or not to honeypot based on the data you have. So.
Sounds like you're talking about a lot of data and processing lots of algorithms over this data.
It is, yeah. I guess the funny coin is security is a data science problem, which is one of those things that I say that is just more of a joke than anything. But that's what it is, right? You're looking at data, you're asking questions, you're listening. We have all the data already. The things like IDS and forensic logs gives us more data to make decisions, but the raw data is there, and you just have to listen to it, right? GeoIP, where are they coming from? Any kind of anomaly, right? Just knowing the distribution of HTTP methods in your system, and when an IP just deviates from that, like there's a reason for that. They're not behaving like everybody else. Why? It might be good, it might be bad, but at the end of the day, something's different, right? There's an anomaly, and just that basic anomaly detection actually gives you a lot of information about what's happening.
So, do you think honeypotting is more effective against known attacks or against new attacks? Because it seems if you're setting up an environment that is going to mimic a vulnerable environment, you have to already know that it's vulnerable. And you kind of already know roughly how the story is going to play out. Whereas something completely new, like for instance the Postgres vulnerability from a couple weeks ago, where they said everybody upgrade right effing now. Yeah. that kind of thing you can't really protect against that necessarily. With honeypotting.
No, so you can't protect that against that, but you also understand what the attack looks like. Those attack have signatures, right? So if you know an attack looks like this, you can actually use something like mod security or any kind of IPS and say, here is the signature of this attack. When you see this, act. One of the nice things that came out of the Ruby on Rails vulnerability was there was a mod security rule written just for that exploit. So people that couldn't patch right away could turn on security, see this coming, and block the traffic, right? So it was an obvious signature, right? It was a very clear payload. So it's not always black and white like that, but it's definitely something to think about.
When I was consulting, I think mostly security was always tacked on after the fact, just like you said earlier. So you build something, and then you have somebody come in and try and pen test, and then you get some kind of a certification saying that you're secure.
Yeah.
That feels wrong. Is
Sure.
there any of that that's okay? And
I mean, so it's better than not doing it all, right? I mean, there's alternative, just don't do it. But it's really, this all comes back to just good development practices anyways, right? This is, the tack it on later is usually a function of a lot of other things that happened before it, right? Somebody built a prototype very quickly to get that concept out the door. What did they do? They didn't delete it and build the real thing. They just kept going, right? Oh, this works good enough. Let's just keep using it, right? This is just all goes back to poor software development practices in general, right? This has nothing to do with security. It's just the choices we make, right? And eventually we make enough choices and we get enough kind of in the red that we'll have to just make the choice to tack it on later. So good design is good design.
What's funny about this because it seems like there's constantly evolving threats in any area, and it makes you really wonder a bit. It's like really what is the benefit of having security design up front if you are going to continuously have to have monitoring and stuff like this, or going to deal with I guess I don't really know enough about that to basically know what the payoff really is and whether it's significant.
So it's about being able to just ignore certain types of problems, right? When you build your login system, right? Understanding that the way you store passwords impacts potential things in the future, right? Choosing the right algorithm to store passwords, right? Knowing that a simple hash is not good enough, or plain text, of course, but that you have to choose the right thing, right? And you make a conscious choice, right? Eventually, there's an offline cracking time, right? There's an inevitability that somebody will be able to brute force this, or there might be even a worse thing. There's like the theoretical timing attack in bcrypt. Things like that are just kind of crazy, but you choose the algorithm you want, and you also choose the level of complexity, level of time the system is going to crunch on something before it emits data, and that is directly proportional to how long it will take to, at a minimum, to crack that. Right, and so what you want to do is understand the value of an account. Right, the user account is it's valued at this amount of money. Right, so you want to make it about equal to the amount of money an attacker would have to spend to crack it. And at that point, you're good, right? So if your account's worth $15 and you have a pretty slow or pretty quick cycle, and the offline cracking time is a week, your brand reputation might suffer a little bit more. So maybe you want to think more about that. But if the value of an account's $3,000. You might want to have, make sure it's, at least 3, 4, 5, 6 months of time for a single hash to get through that.
Yeah, it's kind of funny because it seems like that's the direct cost, but there's so many other, like brand reputation, all these other things which are peripheral costs, and it seems like we suffer from the same thing.
Yeah, but
security that you do with general software design, like not being able to really assess the actual value of what.
That's very true.
Answer.
The problem is you really can't assess the impact of brand damage until it happens, right? Yeah. That's the really tough part. But you can give a dollar and cents value to an account, right? So you can do at least that, right?
So we know the numbers are not really completely real, but that's something we're
You have to start somewhere.
Yeah.
It's all about data and metrics. Like the more information you have, the better decisions you can make, and that has nothing to do with security. That's a fact in general, right?
Yeah.
So yeah, nothing new here really. It's just applying all the stuff we already do to security.
Yeah.
So I'm thinking of 2 words that are going to change the entire security game sometime in the next 5 years. Can you guess what those 2 words are?
I'm thinking of a number.
There's a lot of words.
Quantum computing.
Oh yeah, sure. There's a lot of. I'm uncertain about quantum computing. I went there. I know. So yeah, I mean the amount of power. We've already, the U.S. has invested in it, the military has invested in it, it's a game changer, right? The problem is, there actually is, no joking aside, a lot of uncertainty around how this is going to turn out, what's going to happen, right? There's not enough data yet to make a choice. It's going to make an impact. right now the cost is so high, and a lot of it's locked down. I mean, somebody could of course get access to it and start running all the data through it. But I mean, obviously the amount of power is uncanny. It's taking the time to crunch information way down, right? And
and
potentially,
I've heard it mentioned that it might be the end of public key cryptography.
it's very possible, right? There's huge impacts, right? And I'm confident that just as we have this before, somebody will find another way, right? We're good at this, right? This is what we do as a species, right? We evolve, we learn, we grow, and things get better. It's very possible that this kind of thing does end public key crypto, but that's speculation, right? We have no reason to. That's that meteor, right? We can't worry about that right now. I mean, some people have to. There are certain people that really need to assure secrecy, right? And those people, I'm sure are worried about this and doing the right things. But as generic, non-secret, business owners or members of a business, we have to function with the information we have, and basically, good enough is good enough. Which is an unfortunate thing to say, but at the end of the day, this is about making money in whatever business domain we're in, not about security.
Yeah, it's a very funny thing because years and years ago, I formed a bias against security. I read this book called Untrusting Trust by Ken Thompson. It was like his ACM Turing Award lecture.
Oh, it was the one about the original C compiler, right?
Yeah, basically going and pointing, basically like this labyrinth of choices you can make to go and basically sort of like embed, a way to go and hack into any system that's compiled with C compiler and then leave no trace at all.
Yeah.
And we're looking at that and saying, it's like, well, that just means there's no security, so I'm just not going to worry about it. We're not worried about it, but not look at it as being like a really, inform my perceptions of it. And then, years later you begin to realize, well, it's just not a binary thing. Basically, it's a matter of, like you were saying, going and finding the appropriate level of security for things. But doesn't it feel like there, at least among the general public and quite, often many people in tech, there's this sense of like it's binary. It's like a system's either secure or
yeah, and it's perception, right? It's all a perception problem. And I mean, where I work at Braintree, a lot of what we're doing is credit card transactions, right? And so we have a high level of risk. And we take that very seriously. I mean, it's crucial to our business, right?
Yeah.
But you have that varying state, right? If you're a startup that doesn't take credit card numbers or really anything but somebody's email address, I mean, email addresses are important. You should be careful with them.
Yeah.
But if that's all the information you have, the impact is super low. And yeah, you should worry about it. And yes, there might be brand damage, but is that a bigger obstacle for you than getting to that first release to get the money you need to keep your business going?
Yeah.
Right. So there's a choice, and you have to make it.
It's a very odd thought, but it's essentially since we have like this an escalating war. What do you call that? Like an arms race. Right?
Yeah.
So we're going with all this stuff. So we probably are in a situation where we're basically training better hackers to hack into systems. We're probably raising the bar significantly on new entrants into business. It's kind of like if you have a website, you're starting up, and you're doing various things, you cannot simply afford all the security that basically somebody like Google or Amazon has.
Yeah.
And it's really a strange thing. We're actually functioning in a way where we're actually going and scraping off the bottom end.
It is fun. It's an interesting point to make because security has become a pretty big spotlight recently. In the last couple of years, it's become more and more important. Businesses are starting to really attach to it and understand that it's vital to business function.
Yeah.
And the bar is going up and up for staying safe, right? As new tools come out, one of my favorite examples is Metasploit. It's a wonderful tool, security research tool, but of course can be used for the wrong things.
Yeah.
But I gave a talk about this at RubyConf in 2007. The talk was had a point-click route, right? It was, you have this in GUI. You say, I want this server over there, and I want to do this thing, and I want a VNC window back, and you hit the button, and back comes a VNC window, right? Mm-hmm. It's dangerous because it makes somebody who has no knowledge of this very capable.
Mm-hmm.
And the bar goes up, and then you have to raise your bar to get back to it, and you have to keep up. Just like everything else we do, right? We keep up on the technology, we keep up on security too, right?
But the things people don't. And so as a result, you just have like this, this swath companies, businesses, and stuff like that simply are not
Sure.
going to be able to reach that level of security, which is, a really interesting problem when you think about it.
It is a problem. I think that, so the best part about this, the best part about all this is it's not that hard to learn, right? The basic stuff is simple concepts.
Yeah.
The things we do with distributed concurrency and all this stuff is way more complicated than protecting from cross-site scripting, right?
Yeah.
Like this, you have these complexity problems and these different things that we tackle every day as programmers, right? That stuff is way more advanced than most of the security things that you'll learn. It's just the base level, right?
Yeah. People just aren't used to thinking that.
Yeah, it's just a matter of the offensive mindset, understanding how it works, and then just learning. And so a lot of folks will think that if they invest the time in understanding concurrency, that they'll have a better job. In reality, if they spent all that time and energy into just protecting against the OAuth top 10 alone, right? Just the basics. It'll actually pay off a lot more. Because at the end, you can always add another computer, right? You can't always add, another business when your business goes out because somebody.
That's a strategy, though.
Yeah, it's a strategy. Yeah, maybe that's a choice, right? Again, it's all about the choice for me.
Yeah. Very cool.
Any resources that, as a beginner, you said that it's very easy to pick up? Are there resources that you go to regularly that I should be looking at?
OWASP is a good resource. They publish the top 10 every year, which is the top 10 most, exploited vectors in the web. Basically, it's injection of some sort and a bunch of other stuff, but always cross-scripting, SQL injection, that kind of thing. If you're not into web security, there are other resources. A lot of what we're doing, a lot of what I'm doing right now is web-based stuff. Right? Obviously, the whole cryptography stuff, seen as a different thing. Right? The crypto stuff will take more time to get good at. It requires that stuff is complicated. I'm not a crypto expert. I can apply it, but the math behind it is not my thing. I do know several people that know that math pretty well.
It does feel like it's pretty orthogonal.
Yeah.
It can be.
So understanding how to apply cryptography is nice. Definitely invest in the time and just understanding how to apply what kind of crypto in certain situations. Super important. Doesn't take that much to understand. There's the WebGoat project, which tells you how to attack a site, gets you good at testing. There are several books out there. The Web Application Hacker's Handbook is a nice it's a reinforcement on the top 10 and how to attack. There's a kind of a complementary book, the Web Application Defender's Handbook, which is it's actually a lot about mod security. One of I think it's the lead of the mod security project published that book. So it's a lot about setting up mod security, how to defend your sites, setting up rules, triggers, that kind of thing. So it's kind of a nice, nice pair of books actually. And it actually comes from a series from a little while back called the Shellcoder's Handbook, which was more about some of the earlier, deeper exploits that actually were a little bit more complicated.